Okay, well, very nice being here. I see it's full. So it's a different perspective from here relative to where you stand because all the seats are taken. So first, thank you for inviting me. It seems like at least I enjoyed the previous presentation. One thing just to start interactively, since Bert asked about how many people are aware of 3D printing, so everybody in this room is aware of it. But how many of the people here designed a part which was 3D printed? Okay, so this is less than 10%, closer to 5. How many of you actually hold a part which was 3D printed? This is 20%. How many of you are using anything which, at least part of its design, it was 3D printed? Now the answer is totally wrong, okay? So first, it was like 10%, and eventually each one of you. So everything actually that you touch around yourself, your car, your cell phone, your sneakers, your glasses, whatever, are 3D printed as part of the manufacturing or the design process. And you need to remember it. 3D printing was not invented just 3 years ago and is something new. It is something that exists all around us, and it is heavily used. So it's unique. I'm going to talk about many things around 3D printing. And the first thing is, as also mentioned earlier, about the 3D printing eventually for designers means a lot of freedom. One of the things is the freedom of the design, the capability to create these complicated geometries that usually it's impossible to manufacture it in any other way. So in many cases in the past, people had to think about the manufacturing process, whether I need to drill it or to use a CNC to cut things. And eventually with 3D printing, we are unleashing the creativity of designer without thinking about how you're going to manufacture something. So as an example, for Yuima Nakazato from Japan, he's a very well-known designer, mainly for clothes actually. So not a lot of people think about design of clothes and things related to 3D printing. But if you look on his process for design, it started with concept sketches, then goes to rendering, and finally into a model. So you can see here the different sketches originally for customs. On the first look, it was very hard for me at least to understand what are the sketches, right? And only then, and when you look on the rendered images and on the design, you see the face here on the body? And actually all the stuff which is on the shirt, the bib here, is 3D printed. And the meaning in this case is that people can take their imagination, the thing that they want to create, and don't need to think about how it will be created. There was no way to create this part in any other way. It's so complicated, so delicate, so many details in it. And only using 3D printing technology you are able to create it. So we talked about the freedom of design. Another thing is the freedom of assembly. In many cases, when people are thinking about designing something, they need to think about how it will be assembled. And later on, if you want, I can show you parts that are printed. This is what we call a brain gear. Each part here is moving. I think I have a part somewhere in here. Never mind. So it is printed as a single part, but still have moving gears in it. And the final part that I want to talk in terms of freedom is the freedom of material composition. Usually people think about parts that are made out of a single material. Yes. Well, actually, pass it on. Just let the people touch it. It's much nicer. So today we are in a point where we can work with multiple materials and print parts that are made out of multiple materials. So part of the design is not just to look on the shape, but to define what is the material combination in every location. So just as part of it, Oops, I need to connect here the sound. Can you put a sound of this, please? Yes, we can pass it on as well. Just. Oh, the cable is broken when I'm touching it here. Another try.
Responsibility to do on the latest technologies.
The sound here.
To develop things.
Okay, so I will sing while this is being fixed. This is a movie about people from Bentley Motors. I hope that we will be able to restore the sound soon. But the fact that they are printing things out of multi-material. Why is it important to print things out of multi-material? Because if you look on the internal of the car, there are different parts. One of the things you will see on the screen here, okay, just before I move, is, for example, the wheel of a car, and the tire is actually made out of rubber, while the rim is something more rigid, and all of it can be printed in a single print. Okay, so since it's not working, let's just continue and talk about, again, continue talk about multi-material and what does it mean for us. And since most of you are not aware of multi-material, this is more of the place I want to put more emphasis on. So one thing is maybe to ask, how many people here know what is a voxel? Not that many. Bart mentioned it earlier. Here. So voxel, how many people here know what is a pixel? Everybody. You have a lot of megapixel in your cameras, right? So voxel is just like a pixel. The only difference is three-dimensional. So instead of having these points, you have a three-dimensional object. Here is an example, one small cube. So it's a volumetric pixel. And to some extent, you can think about 3D printing, and the way at least that we think it in some of the inkjet-based printers is that we have these voxels, and in order to create a three-dimensional object, the only thing you need to do is to think how to put this voxel one on top of the other, or where to put them in space. So what is the most common voxel that each one of you is familiar with? Yes, you can say it aloud, it's okay. So the most common voxel is a Lego brick. All of you are familiar with Lego bricks, okay? Right, you're familiar with Lego bricks. So if you look on the smallest Lego brick, okay, and eventually try to build it out of the printer that Eric was talking about here earlier, eventually there are about 4 million small, tiny voxels that are building this small Lego brick. So to some extent, and this is what I'm telling my son, I go to work and I play with Lego bricks the whole day. And maybe to say, do you know how many Lego bricks are manufactured every year? A guess? 10 billion, very close to the number. Very close, good. So by the way, if you do the calculation about this, then in each print that we have, depending on the size of the printer, we have something like between 10 to the 12 to the 10 to the 10 to the 11 to the 10 to the 12 bricks, tiny bricks. So within each print, we play with more Lego bricks than the whole world is playing in 1 year. In a printer, there is more than one voxel. Actually, even in the most basic printer, there are two voxels. One of them is the model, and the other one is a support material. We are building something with our Legos, with our small voxels, and at the end of the print, actually, we are washing away the support, the yellow one, in order to create the model. Of course, I think you gave the example of the pyramid, that from far behind it looks like a pyramid. When you're very close, it has the shape of the cubes. The same thing actually is with all this 3D printed stuff. It looks very smooth, but actually it's made out of these tiny, tiny voxels. In some printers, we have, which we call them the multi-material printing, or it's the brand name is known as Connex. We have more type of voxel. We have, for example, we have a white voxel, we have a black voxel, and we have the support voxel. And again, we are playing and deciding where to put the white voxel, where to put the black voxel, where to put the support, and this is how eventually we built the whole object. And we can choose what voxel to play with. To some extent, we are working, we have a team of, I don't know, more than 40 chemists that are developing materials for the company. And we are working to control the properties of this tiny voxel. So a tiny voxel can be black, it can be blue, it can be gray, it can be translucent. This is what Eric showed in the previous presentation. And it can be semi-translucent, and it can also feel like rubber. So here, can you pass the shoe, please? Here, just to understand, it's a bit heavy, but you will find out that it's made out of more than a single material. Part of it is not just different colors, but there is also a different feel. Some of it will be rubber-like, some of it will be completely rigid. So we talked about the design freedom that we have with 3D printing. We talked about voxels. Let's continue quickly. How much time do I have? So what can we do with this multi-material printing? So the simple example, if I can print with black and I can print with white, it's very simple. I can create parts which are black, and I can create parts which are white. That's very simple. Now, the other thing is I can create what I call mixed part. I can combine two materials together. Here, this is actually the same as on the picture here, okay? This part made out of a translucent part and an opaque part. It is, of course, someone's leg. I hope nothing happened. Okay. And so we can create this, we call it usually a mixed part because it's made out of two separate materials. Now, the other world that is, for me, more interesting because it's more on the research side is what we call digital material, and we will do another zoom into this world of digital materials. So this is more technological, I know, but hold on for a second. Don't worry, everybody. There is no exam at the end. So digital materials are engineered materials. The fact that I can create a part and locate the voxel one next to the other exactly where I want enabled me to control the microscopic structure. And eventually, I can create this structure in different way. I can create this structure to be homogeneous or heterogeneous. I can make it isotropic or anisotropic. I can control it to be depending on the geometry. For example, you can see how here the structure are following the geometry. So the simplest way to look, or that everybody has intuition, is about homogeneous digital material. And here I assume that I have two parts, or two voxels. One is white, and the other one is black. And I can create random structures. Here is about 20% black and white, 40%, 60%. And what I just showed you is usually called in printing and in other places dithering. And it's very easy when you take white and black and mix it, you get gray. I mean, it's not such a big deal, right? And I hope you see this blue dot here, okay, on the screen. Eventually, actually, it's not really blue. It is a cyan and magenta, and the fact that we are doing dithering creates for us the effect that actually it's blue. But actually, it is not blue. And the more interesting part is that when you take hard and flexible, just as the shoe that I passed by you, if you mix a hard or rigid part with a flexible, with what we call a durometer level or shore level part, you can create different shore level, and this is how we are creating different durometers and simulate different type of rubbers in 3D printing. So the only thing that is happening inside the shoe that you're holding is that automatically the software determines the ratio between the two material, and based on it, we determine the color of it and also the mechanical properties. And eventually, the fact that we were able to create different mechanical properties caused us to, that's not mine, right? Part? It's yours. It enabled us to create, here is an example for a print between two base material. One of those is translucent, the other one is rubber-like, and we can therefore create different effects of translucency, what we call smoke level, so semi-translucency, and also different shore level and rubber capabilities. This enables people to do a lot of things as part of their design, to design the grips for your glasses or mouse pad, whatever you want. But let's right now look on another way of, in terms of combination, and this is to create things that are geometry dependent. And I will pass, let's pass quite a lot of parts in here. Just here. Just give, not necessarily, I mean, give it several people. Throw them away, exactly. So what all the parts that I'm passing have are a mixture of 50% a rigid material and 50% is a rubber-like material. However, it's not uniform. People are used to touch parts, and this is all our manufacturing process, are based on the fact that things are uniform. In this case, the parts are not uniform. So those of you who still didn't touch it can look on the screen and see the different structure that I'm passing. Some of those are like fibers. We call it a sandwich structure. In the X direction, in the Y direction, and in the Z direction. And see what happens when you're bending it. I mean, those of you who already touch it feel it, that actually it doesn't feel standard. Okay, it's not uniform. People are used to uniform world. But in this case, things are not uniform. And as we bend them, they behave different in a mechanical way for us. So we are, this is, I will say even the good news, we are able to control the mechanical properties by creating the local or the internal structure. And you see here, when I'm trying to tear those, probably some of you would break it, right? Please don't. A little bit, maybe. But you see that the mechanical properties are different because you need to apply a different strengths in order to turn it. So first it's fun, okay, and it's different type of interaction, but it has also a meaning. Now I'm not going to bother you too much with this, with the technology part of it, but I can tell you that once we were interested to create stronger material, much better material, we were limited in terms of technology in the world of photopolymers by the strengths of the parts. And at some point we came into a point where we created two base material and a software algorithm that is taking these two materials, combining them into something very strong. Okay, this was I think the first example where before that this would break if I would stand on it. But as we created this composite material, we were successful enough to create something extremely durable using computer algorithms. So this is a material that we introduced 2 years ago. She said 5, you say 2. You need to decide. So we introduced it and recently introduced its next generation. I will not go right now into the movie I wanted to show, but maybe to say one of the new things we found out is people are taking this material and using it in order to create molds. So again, we are using 3D printing in order to create mold. Why? Because usually it will take you to create a mold quite a lot of time. There is a movie on YouTube you can see about 8 weeks and 40,000 euro to create sophisticated molds. And maybe to say, with this technology, we are able to print the mold and within 24 hours and a cost of less than 1,000 euro, have a printed mold and then create a part. As I said, this movie I will not go through. I will just go through several additional slides to talk about what is coming more next. We're looking on more what we call gradual compositional variations, on more combination between material. These are pictures out of a presentation in Centre Pompidou in Paris. So it's an art exhibition by Neri Oxman. She's a professor at MIT lab and an artist. And just for you to understand what is possible to print, okay, all these are printed. This is out of material that are not released today to the public. But whatever you see here is 3D printed, not painted, where we are controlling all the voxels and creating, therefore, this combination between colors. I can say beautiful combination. So these are things, as I said, right now it's more in research and in art world, but you can expect this to become and be available at some point. Other things about graded material, here is an example of data taken out of CT and converted automatically into a graded material. So actually you can see here the bones. The external part actually is rubber-like. So eventually it is used for simulation for surgery. So you can actually cut this part and actually get and touch the bones, etc. So what is coming in front of us? I mean, this whole world of new digital material is going to grow. You will all have tools that will enable you to design in multi-material. We will create more what we call parent material or base voxel material that have more properties available. There is a new coming 3D file format called AMF that is replacing STL as this called additive manufacturing format, which includes multi-material. And of course, we will have multi-material manufacturing and further exciting products. So, by the way, this is an example of 3D printed speakers, printed by people from Autodesk. Okay, so if there are any questions, you can already ask me while you watch this beautiful stuff. It's 3D printed, multi-material, and music and light, the same place. Let's turn this off, right? Okay, thank you.
Who would like to ask the first question?
Dr. Ofer, do you think there will exist a separate industry of software that complement the 3D printing, or it is the same within the same industry?
I mean, today there is a big industry. It started more than 20 years ago for 3D solder modeling. And everybody is using, I mean, today all the 3D design, or a lot of the design, or some part of the design is done using this software. The thing will happen is that the 3D printing software will evolve to cover better the capability of 3D printers. It will not be a separate industry. The existing industry will evolve.
Next question.
Hello. I'm really interested in the double material printing, and now I see it's two plastic components. But do you think in the future you could also mix glass and metal, or metal and ceramics, or metal and rubbers, so that it's more different materials, getting a more different experience?
Well, in terms of the future, it's safer not to predict too much. But yes, there is no reason there will be additional technologies that will enable multi-material printing, and not necessarily things in this, let's say, I mean, rubber and rigid are very different, of course, but there will be others that be available.
Okay, I think we have time for one final question.
I mean, this is all for industries. How do you see this technology being applied to the home user? Is it happening, or how far are we from having our own 3D printer in the home?
Well, it's a great question. To some extent, I mean, we acquired MakerBot about 4 months ago, and selling a lot of printers for the what you call prosumer market. A lot of those goes to home users, and more people are experiencing it. So I would, on one hand, say yes, more and more people are going to buy printers at home. But I have actually a more surprising answer to you. You already have a printer at home. Each one of you can go log into the internet, create parts, print it on the internet, and have those shipped to you. So it's not necessarily that you need it physically to sit, under your desk, because one day you may want to print something in silver, the other day you may want to have it in metal. And it's out there available. And part of the recent hype, this is mentioned about 3D printing, is to make people aware that this is possible. First, that they can design, that there will be the tools that people will be able to design, and then that using the internet, using the connectivity, they will be able to send this file and get those printed. So maybe it is expensive. It's not cheap yet, but it is available.
Okay, thank you very much, Ofer.